Hello! Welcome aboard, everyone. Welcome to an adventure. This is our regular weekly archival adventures. I am your host, Anthony Wright Day Hernandez, aka Rogan27, Community Collections Archivist here at Virginia Tech, and I hope that your week is going well. Let me see who is in the chat. I see NeoGets. Hello, hello. Hi, Matt M33. Hi, Simsilica. P squared. Indeed, maths. Hannah, hello. It's good to see you. Only sort of here working. I understand that. If I have 1 penny and the year is 2025, how screwed am I? Well, 1 penny does not a long way go presently. So yeah, welcome to yet another stumble through archival materials. See what's there. Have fun. I don't know. So yeah, today we will be looking for the sum of whatever we can find, I suppose. I don't know. We're gonna calculate a good time. So yes, we are going to be looking at an 1857 question mark mathematics notebook from someone named Samuel Berger. Presumably, if you pay him Tuesday, he will give you a burger today. I don't know. Yes, the Samuel Berger Mathematics Notebook, 1857 question mark. I do believe there is a formula for the perfect party. One of those silly maths papers someone did get years ago. Probably. Let's see. You can see it's 0.1 cubic feet. It's one folder. It is a single notebook. I ran across it and I was like, I wonder what that's all about. And I looked at it and it seemed pretty interesting. So Samuel Berger, born 1820, died 1889 of Botetourt County, Virginia, was a captain in the Confederate Army and served as an aide for Jefferson Davis during the American Civil War. He also served in the Virginia House of Delegates from 1877 to 1879 and was Botetourt County's surveyor from 1870 until his death in 1889. In addition, he was a teacher and a farmer. I have not personally researched him, so I don't know any more than that. The collection is a handwritten notebook with math equations and problems from Botetourt County, Virginia, created around 1857. A majority of the problems are algebraic equations, but there are also a number of word problems included. A signature on the inside cover reads Samuel Berger. So really short, simple finding aid. If you need to refer to it again, the link is there in the chat. Let's see what this is all about, and you all can discover why I thought it seemed interesting enough to spend 2 hours looking at. Because I glanced at it long enough to evaluate, is this interesting? And my evaluation was, yes. Yes, I would say this is interesting. You'll note it is in somewhat of a dilapidated condition. This has not been restored, and so you can see the spine covering is barely attached here on the back and is gone everywhere else pretty much. But it lets you see the little the way the codex is put together with the little sections of leaves and stitched together. You've got some of the stitching coming out. If you don't know how books are made, it's an interesting process. We're going to attempt to be gentle. Do not adjust your settings. It is indeed blue. And I don't know why, but the signature inside is upside down. I also don't know what it says after his name. Samuel Berger in I'm gonna zoom in. You all can help me see if I can figure it out. It definitely says in B. I'm uncertain. It looks like B-R-O-B, but I don't know what it is in fact. Anyway, hi Stephen Joyce. We're doing a perusal of some maths today. Bookbinding is interesting. And if you look at the history of recorded text, books are codices. The actual physical form of a book, where it is bound together like this, that is a codex. Before codexes were scrolls. And before scrolls were tablets. And after codices, we started to scroll the internet. And then we started scrolling the internet on tablets. So we went tablet, scroll, codex, scroll, tablet. But not a codex Astartes. What is a codex Astartes? No, it's just the term for the physical form. Ah. I see. It's from 40K. Warhammer 40K. Yeah, no, it's been a long time since I played any Warhammer 40K. Like, more than 30 years. Well, no, so let's see. Yeah, it would be time to bounce back to scroll, and then we'll get up to codex. Because originally, tablets, they were small. They were limited in what they could contain. And then scrolls could contain a lot more information, but it was really hard to tell somebody how to find a specific piece of information if it was like far down the scroll. So the codex lets you have the page numbers and the index, and you can jump to a specific part of the information quickly. That was the advantage of the codex over the scroll. And then internet scrolling, just it being on the internet. But yeah, then tablets allowed us to carry around the internet, which gives fast access to informational resources. Unfortunately, just like printed resources, you have to know whether they're reliable. The information that's there may or may not be true. Just because it exists does not mean it's true. Oh wait, the flexible screens they have in phones. Maybe we get super long screens that can roll up. That is not out of the question. I have definitely seen foldable screens that potentially you could just roll up. At least as a concept. So I have one bookmark in here, and that's because it was an item that I found while I was looking for a good part of this to make a picture out of. So I'm going to start here just because it seemed like this was part of why I was like, yeah, I think this is pretty interesting. Because how do you all feel about word problems in mathematics? I know they were not the most popular problems in mathematics when I was in grammar school. These, however, are really interesting. I wish I had a bowl to be made for me, just to hold 1 gallon of tea. How wide across must the mouth then be? A half a globe its form should be. That's the problem. That's the word problem. That's a freaking poem. I wish a bowl to be made for me, just to hold 1 gallon of tea. How wide across must the mouth then be? A half a globe its form should be. Yeah, these are, and yes, a gallon of tea? Yes, please. And so then the actual calculation that's on here we can look at, it appears to me to be primarily long division. But I've got, let's see, 282 inches in a gallon. I don't know, 0.5236 divided by 564. I don't know where these numbers came from. I guess, 282 times 2 is 564. Inches in a gallon. That's an odd measurement. Different gallon than we use these days then? Yeah, I'm not certain. Like, I've never thought of gallons in inches. But where's the 0.5236 come from? I am not a maths expert. Like, the long division makes sense to me. I just don't know where that number came from, or why we doubled the number of inches in a gallon, or how we figured out how many inches were in a gallon in the first place. The answer that they calculate out is 10.25 inches. So basically, the bowl, the opening at the top of the bowl, the circumference of that needs to be 10.25 inches in order for the bowl to be able to hold a gallon of tea. However, I feel like there are some assumptions here that I'm not privy to. Yeah, I assume it's a 2-gallon sphere because... well, yes, it would have to be. Because, okay, so we want a bowl. It needs to hold 1 gallon. How wide across would the opening be? and its shape is half of a globe. So what they're really asking for is the circumference at the center of the globe. Congratulations, SimSilica. Congrats on being selected as VIP for the stream. Also, I don't know if I said hi to you earlier. Hi. But yeah, so it's a word problem where essentially what you're looking for is the circumference of the sphere. So it's a complicated way to avoid taking a cube root? Okay. I assume the 0.5236 has something to do with calculating a circumference of a sphere. But why? But why in regard to what? Like, it's a lovely word problem that really is just asking, calculate the circumference of a sphere. That would be able to hold 2 gallons. To drink lots of tea, exactly. Okay, I'm gonna read another one now. Divide $3 between 2 men so as to give one a third more than the other. What will each receive? This one he actually like explains. Rule. Divide number of dollars so that the one will get 2 parts and the other 3 parts. So $1.80 and $1.20. Oh, okay. Yeah, the original so it's a math notebook. So it was just a word problem presented as a poem. I wish a bowl to be made for me, just to hold 1 gallon of tea. How wide across must the mouth then be? A half a globe its form should be. Which is a lovely way to present a word problem. A equals 2/5, B equals 3/5. For the dollar problem. But it's money though. So you've got $3. You have to be able to break those 3s into. You have to know how money works to do that one. But I'm gonna jump back to the beginning and see what this page about double position says. Also, I love the handwriting. It's actually surprisingly easy to read, this handwriting. It would be awkward to drink from. Yes, it would. It also would not be able to stand on its own. It would have to have some sort of cradle to hold it, because if it's a perfect half sphere, it's not going to balance. Word problems are good because they give real-world applications for maths, but you have to know how to read them sometimes, as there can be phrasing quirks, especially when they're written in poetry. July 22nd, 1857. Well, okay. Why did we have a question mark on the date then in the finding aid? The first page is dated July of 1857. We might not know when it ended, but it definitely starts in 1857. Let's see. A person goes to a tavern with a certain sum of money in his pocket. When he spends 2 shillings, he then borrows as much money as he had left. And going to another tavern, he then spends 2 shillings also. Then borrowing again as much money as was left, he went to a third tavern, where likewise he spent 2 shillings, and borrowed as much as he had left. And again, spending 2 shillings at a fourth tavern. He then had nothing remaining. What had he at first? Okay, so he ends up with 0. Which, see, me, I would start with he ends up at 0. And he spent 2 shillings. And if he spent 2 shillings, and at the place prior, he borrowed as much as he had left, that means he borrowed 1 shilling. And he had spent 2 shillings there, and at the previous one borrowed as much as he had left, so he had to have 4 shillings. So I would work backwards myself, starting with the 0 and then just work backwards, because how many times did he stop and spend? 1, 2, 3. Okay, so he went to 4 taverns, spending 2 shillings at each, meaning in total, he spent 8 shillings. And if the first, see, now is when I would need to write things down. The answer is here, but I'm gonna, okay, so he ends up with 0, 2, had 1, borrowed 1, spent 2, so borrowed 2, meaning, borrowed 2, spent 2, so 4, it's 4, 3, 2, if he had 4 going into the second one, he spent 2, borrowed as much as he had left. I work it out that he would have had 6 shillings to start. Because he had 6, spent 2, borrowed 4, meaning he had 8. No, that's wrong. Yeah. Anyway, I give up. I don't give up. I just know that it's wrong, and I'm not going to spend all of your time watching me try to work through a math problem without spending a bunch of time writing it down or using a spreadsheet. Because I cannot do calculations in my head. I will get them wrong. Let's just look at how they went about it. Okay. First supposition, S. Second supposition, S. Okay, so yes, S. 10, 2 spent, 8 borrowed. So 16, 2 spent, 14 borrowed. 28, 2 spent. No, that leaves him with 50, not 0. So that is definitely wrong. A dozen, a gross, and a score. Plus 3 times the square root of 4 divided by 7 plus 5 times 11 is 9 square and not a bit more. Poem by Lee Mercer. It flows nicely. Second supposition, 5. I think this one is right. Because 6 is wrong. Because if he had 6 and spent... Yeah, no, 5, it has to be 5. Because then he would have spent 2, had 3 left, borrowed 3, had 6, spent 2, 4 left, borrowed 4, had 8, spent 2. Nope, that's wrong. It's not, it can't be 5. Is it 4? So if he had 4, spent 2, that would have him borrow 2 to get 4. So it would start at 4, and then that would be 4, spend 2, borrow 2, end up with 4. Spend 2, borrow 2. It would just go on forever then. So that doesn't work either. But there's an algebraic way to solve it, according to this. Let's see, x minus 2, x minus 2, 2x, 4. Actually, I'm not certain how he's noting things. Is that actually a minus or not? X is 2x, 4 minus 2. 2x is 6. Yeah, I don't understand his notation. But he does have x equals 5. No. Well, his answer is 3 shillings, 9 pence. 3 shillings 9. And I don't understand how many. I don't know how many of these go into a shilling, because that's a monetary system I'm not super familiar with. This is actually surprisingly a complicated problem to work out, which I actually tried to do this one in my head when I first opened this notebook, and I gave up because I was busy doing other things. But pre-decimalization of coins, right? So how many pence in a shilling? 12. Okay, so if he started with 3 and 9, spent 2, leaves them with 1 and 9. 1 and 9 is 2 and 3 when doubled, right? No. Brain. Okay, so that would be 2 and 18, which is the same as 3 and 6. Minus 2 is 1 and 6. Doubled is 2 and 12 is 3. Minus 2 is 1. Borrow 1 gives you 2. Spend 2. Okay, yeah. And there it is. That's... I would never have figured it out because I needed to know how many pennies were in a shilling in order to do that problem. And I did not know that it was 12 pennies to a shilling. But once you know that it's 12 pennies to a shilling, 3 shillings and 9 pennies comes out right. And I wish I understood how this was being noted here, because I don't quite understand this algebraically calculation. But I'm not going to dwell on it. Like I said, I find math interesting. I'm not good at doing it in my head. And the reason I found this notebook interesting is more for the form than for the actual mathematical problems. 20 persons, men and women, dine at a tavern. The share of the reckoning for one man is a certain number of cents. 30? 80? I'm uncertain. I think that's a 3. I think that's 30 cents. That for one woman is 20 cents. Yeah, it's 30 cents. So a man costs 30 cents, a woman is 20 cents, and the whole reckoning amounts to $4.50. Required, the number of men and women. Answer, 15 women and 5 men. So that's a similar kind of calculation to the one that we just had, and much less poetic. A banker has 2 kinds of change. 10 pieces of one make a crown, and 20 pieces of the other make a crown. Now a person wishes to change a crown into 17 pieces of money. How many pieces of each must he have? 3 of the smaller and 14 of the larger. I love how the calculations are divided by just, I'm just gonna cross this out and give me all of that room. Okay, now I've done this calculation here. Just gonna zoop. And different calculation. Oh, wow. There's some notations here. I'm not gonna read all of the maths on it, but I'm curious about the notes. Second method for the lower sum, multiplying the number of pieces by the less piece, subtract it from $1 and divide the difference by the difference of the value of the pieces, gives the number of large pieces. It is required to divide $1 in 6 1/4 1-cent pieces and 5-cent pieces in such a manner that there shall 17 pieces? How many of each kind will there? Answer, 12 of the larger, 5 of the smaller. Huh. That's a different answer than what they got before? So is it really just I don't know. Let's see what this one is. A person buys 12 pieces of cloth for 140 crowns. There are 2 are white, 3 are black, and 7 are blue. A piece of the black cloth costs 2 crowns more than a piece of the white, and a piece of the white cloth costs 3 crowns more than a piece of black. Required, the price of each kind. See, these sound more like the word problems that I would have encountered in school that were not as fun. I'm gonna look for more poems. Okay. 1/6 of 1/4 of the year that I was born in, together with 1/7 of my age, equals 3 times my age added to thither. No, added to 13. What is my present age and in what year was I born? This one is a bit complicated. 1/6 of 1/4 of the year that I was born in, together with 1/7 of my age, equals 3 times my age added to 13. What is my present age and in what year was I born? Allowing present time to be 1773. It's interesting to me that his calculations always start with a supposition. So that just seems like a guess out of nowhere. Like, suppose age 24. 1/6 of 1/4 of 1773 equals 73 and 7/8. 1/7 of okay, but it says 1/7 of my age, which is the age was not 28, so it wouldn't be 1/7 of 28. It's 24 was your supposition. So that doesn't seem like a correct calculation to me. I do think algebraically is the way to go, where x equals the age. 1773 over 24 plus x over 7 minus x over 24 equals 3x plus 13, which works out to 21 years, and the answer, 21 years old, born in 1752. I was more interested in just, first you have to be able to parse the word problem and understand what it's saying. Oh, this one's written interestingly. If 1/4 of your money you give unto me, said I with a smile to be and to see, with 1,000 bright dollars I then should be blessed. 'Twould pay off my debts and set me at rest. Said B to A, C, I plainly behold. If 1/5 of your cash in my pocket were told, the same sum of dollars my pocket would grace, and a satisfied smile enliven my face. If 1/6 of your sums were added to mine, said C to B, A, I would not repine. For the same sum of dollars I then should behold each time I approached my purse to unfold. Ye lads who with learning and genius are blessed, tell the number of dollars each man did possess. With a heart full of friendship, I'll give you my... I'm uncertain what this last word here is. With a heart full of friendship, I'll give you my... hand. Whew. It's because it was scrunched up at the side of the page. It was hard to read. With a heart full of friendship, I'll give you my hand and say that position you well understand. and say that position you well understand. This one's great. I love this one. If a fourth of your money you give unto me, said A with a smile to B and to C, with 1,000 bright dollars I then should be blessed, would pay off my debts and set me at rest. Said B to A, C I plainly behold, if a fifth of your cash in my pocket were told, the same sum of dollars my pocket would grace, and a satisfied smile enliven my face. If a sixth of your sums were added to mine, said C to B, A, I would not repine. For the same sum of dollars I then should behold each time I approached my purse to unfold. Ye lads who with learning and genius are blessed, tell the number of dollars each man did possess. With a heart full of friendship I'll give you my hand, and say that position you well understand. Apparently it works out to A having $626.18 over 107, B with 719 with 67 over 107, and C with 775 with 75 over 107. I don't quite get the fractions, but I love the double S's. We're in that time period where the double S's are a thing. Rule. Suppose any convenient number for A. Subtract it from 1,000. Multiply the remainder by 4, and the product will be the sum that B and C must have to correspond with the supposition. Then, by double position, find the part which B must have of it to correspond with the condition of the question. Subtract it from the sum of B's and C's, and the remainder of the part belonging to C. Add together the supposed for A's and B's proportion. The sixth part of that sum added to C's must make 1,000, and the difference will be the error. The second error is found in the same manner by supposing a different number for A. In this example, when we go to find B's part, which is to correspond with the condition of the question, we have supposed 1,600 plus 1,800, which subtracted from 2,400 leaves 500 and 600? I'm uncertain. It's some ink smudging there. And my brain does not do math quickly in head. Then the fifth of 400 is 80, which added to the 800 plus 600, 800 plus 600. With the fifth of the 1,600 plus 1,800 gives 1,200 plus 1,040, from which 1,000 is subtracted and leaves the errors 200 plus 40. Whew, I would... Even understanding the explanation would take me having to take notes. Secondly, we have supposed for B, 900 plus 700, which subtracted from 1,600 leaves 700 plus 900. The fifth of 600 is 120, which added to the 700 plus 900, with the 1/5 of the 900 plus 700 gives 1,000 plus 1160, from which 1,000 is subtracted and leaves 0 plus 160. By making the position statement, we get for B 550 plus 700. For C's, subtract B's 550 from the 2,400, and the 700 from 1,600, and we get 1,850 plus 900, which is C's part. Then add first of A's plus B's plus take the 1/6 of it and add it to the 1,850, then add the second part A's and B's together and take the 1/6 of it and add to the 900, subtract 1,000 from them, and we have the errors to find C's. Oh, wow. I feel like reading the explanation of how to do the calculations for the poem I feel like I was the math gif with all the numbers in the air around me. Hi, Bastion Cider. You got to get a prize for just reading through this all so cleanly. I'd be stumbling all over the place. Yeah. The only things I was stumbling on was where there were smudges in the numbers or smudges in the ink. Otherwise, it's not... The handwriting is pretty easy. It's interesting to me... He doesn't seem to be consistent with his double S's. Although, I'm glancing through this and I don't actually think in this entire section here, there aren't actually that many occurrences where the long S is called for. So it's not always a double S, it's the long S, and usage of the long S is inconsistent. Like the grammatical rules for when it was supposed to appear are just as wonky as most English grammatical rules. Like we all, as kids, learned I before E except after C, and in cases like they and way and or nay and they and whatever. I don't remember the entire thing, but even that, the exceptions that are listed are not all of the exceptions. The long S is supposed to be there if it's a double S, if it is the second S in the word. So like if the word has an S and then some more letters and then another S, the second one is supposed to be a long S, except if it's preceded by a certain letter or followed by a certain, I don't remember. It's complicated. It's like math, deciding when the long S is supposed to be used, except when sounding like A as in neighbor or way. Thank you, Bastion Cider. This is me trying to recall things from elementary school off the top of my head. Whew. Okay, that's a more traditional one, not a poem. I'm looking for the poems. These pages are all still the calculation for A, B, and C's money. Oh, here's an example of that. The long S plus S. So the double S where the first S is a long S and the second S is not. That's how that goes. I get the rules. It's such a stupid rule. It has more exceptions than matching cases. Are you referring to the I before E or the long S? Because the long S has a bazillion exceptions as well. 3 nights successively, a nest was robbed of its eggs. The first night, half the eggs were taken and half an egg more. The second night, half the remainder and half an egg more were taken. The third night, half the remainder were taken and half an egg more, at which time the number was reduced to 1. How many were there at first? I rather feel it's a little problematic to steal half an egg from a nest. Exactly, SimSilica. You write your cursive Fs similarly to the long S. They are very similar. And it can be difficult. So there's actually an example right here. Here's the long S. And here's a cursive F. Actually, even closer. Long S, cursive F. They are almost identical. and it can be really difficult to distinguish them in some people's handwriting. Not if you boil them first. Was not worth it. Yeah. I actually think that the long S in form is more like a lowercase j, only you extend the top of it up further and don't put a dot on it. Find the loops of the long S shape flow nicer with a nib than how you're supposed to write F. I would understand that, yeah. I think we should still use the long S, but we won't because nobody learned it and it's too complicated. And nobody's learning handwriting anymore anyway. No. We're not calculating apples. I'm looking for the poems. Because those are the ones that have been the best. Alright, I'm gonna zoom out until I find one that we want to look at. Also, if you see any interesting math on the page, I'm not opposed to looking at it. I just don't know that I'll understand it. Nothing's stopping you from using it if you don't mind confusing anyone who has to read your notes. When I'm taking notes for myself, I will sometimes just write them in Pictish script or Pictish writing. It's not completely traditional, but it is a fully developed alphabet. And most people can't read it. But I learned it in high school to send notes to a friend, and so sometimes when I'm writing things just for me, I write it in Pict. It didn't help that your first school taught different cursive to your second school. Mostly an issue with G and J. I was given a workbook to teach myself cursive. That's a long story, but I didn't actually get formal instruction in it. That? Okay, I'm struggling with the first letter, which is embellished, and I can't tell if it's an H. I feel like it should be an F, though. Who was the king of Syracuse? Oh no, it is an H. It's Hiero. I was unfamiliar with that as a name. Develop the habit of writing notes with the odd kanji of if the kanji is quicker to write than the English word because of trying to learn Japanese. Yeah, I mean, any sort of shorthand is great. I actually wanted to learn actual shorthand for a while, but I never had the time, ironically. 16-bit Eric, hello! Welcome in, everybody. Hi, Raiders. Welcome. Hi. Welcome in, Raiders. This is Archival Adventures, and I am your host, Rogan27, aka Anthony Wright Day Hernandez, Community Collections Archivist here at Virginia Tech. And this is the once-a-week show where I look at things from the archives, most often things I've not seen before, and we see what we can learn. It's always an adventure. Welcome in. I hope that the rest of your stream went well, Eric. I very much appreciate you all coming in. If anybody who was here is not already following 16-bit Eric, I do highly recommend his channel. He is a wonderful streamer with a wonderful community. And if you are at all interested in tabletop role-playing games, definitely need to follow 16-bit Eric. Let me see. I'm looking to see who all joined. Hi, Ralph Exiv. But yeah, welcome in, whoever came in with the raid. Hi, welcome. We are today looking at a math notebook from 1857. And not really getting far into the maths of it, but the word problems are poems more often than not. Well, at least a few times, and they're fun to read. Shadows, thank you so much for the bit. We are going to be attacked by your second worst enemy, Pretty Witchery, which is advertisements. The unavoidable advertisements that the Twitch platform insists must happen. We're going to let 3 minutes of ads run so that people joining won't get pre-rolls when they come to the channel. So we're going to take a quick break, and I will see you all in a couple of minutes. Okay. The ads should be ending very shortly. So we're gonna prepare for a resumption of the maths. I have jumped into the future. As you can tell by the Marty McFly hat, which is really fun when green screened. Okay, ads should be done now. I'm gonna take us back to the document. Okay. Let's see what this one... Hiero, king of Syracuse, ordered a crown for himself of pure gold, whose weight should be 5 pounds. But finding there had been copper mined within the gold, or sorry, copper mixed within... That's the worst stumble I've done all day. Alright, let me try this again. Hiero, king of Syracuse, ordered a crown for himself of pure gold, whose weight should be 5 pounds. But finding there had been copper mixed with the gold, he made application to the famous Archimedes to detect the fraud. Archimedes procured 2 other masses of the same weight, the one of pure gold and the other of copper, and threw each of them separately into a vessel full of water, and found the weight of the water expelled by the copper to be 28 ounces, that of the gold 13 ounces, and by the crown 16 ounces. That is their specific bulk. That is, their specific bulks were 23, 13, and 16. What was the true weight of gold and likewise of copper in the crown? Apparently 1.5 pounds of copper and 3.5 pounds of gold. Words are heard, yes, sometimes. I'm not even gonna attempt to sit here and parse out exactly how that was calculated. This, I believe, all of the problems at the beginning here are double position problems. You're all free to calculate these on your own if you want, but I'm just looking for the really interesting ones that are fun to read, because I think it's really cool how they were presented. I'm looking for more poems. A pink gold crown rather than a yellow gold? Yes. Although rose gold is very, very pretty. I like rose gold. literally a classic problem. It was first written in Latin, the gold and copper one. Oh, we got a poem. I just love that some of these word problems are poems. A gentleman 2 daughters had, and both were very fair. To each he gave a piece of land, one round and the other square. At 40 eagles the acre just, each piece its value had. The dollars which encompassed each, for each exactly paid. If crass a dollar be an inch, as it is very near. If cross a dollar be an inch, as it is very near, who had the better portion that had the round or square? This one is a, it is a poem. It's one of those frustrating poems that has a meter and feels like it should rhyme, but doesn't actually rhyme, which makes it hard to read. The writing is so pretty, it makes you angry. A gentleman 2 daughters had, and both were very fair. To each he gave a piece of land, one round, the other square. At 40 eagles the acre just, each piece its value had. The dollars which encompassed each, for each exactly paid. If cross a dollar be an inch, as it is very near, who had the better portion that had the round or square? Honestly, I think that like the handwriting is lovely, indeed. This was done with a fountain pen. B, formal education in cursive handwriting was definitely a thing in the 1850s or 1830s. C, the pace of life was slower, so it was possible to take more time to handwrite something out. Today, if somebody's going to handwrite something, oftentimes it's really sloppy because A, not as much practice, and B, we're trying to write it a lot faster than they would have written it back then. Because we're always so rushed. Trick to pretending you have better handwriting, use an italic nib. I do not know the differences between nibs. I do think we have some collections that might be relevant to that, and we might have to look at some handwriting collections and learn. I mostly want to write fancy letters, and to write letters to hand out to your D&D players. I mean, I can find some old handwriting that is entirely illegible if you want, just to make you feel better. Let's see what else. Oh no, that looks like geometry. Got another poem. Two drovers meeting on their way and thus they said it is true. If half your flock you give to me, I'll have just 82. Nay, friend, the other soon replied, add but a third to mine. Of your best sheep, then I shall have 129. His answer was exactly true. No scholar will impeach. Then by your knowledge show to me, how many sheep had each? Shining, shimmering, slanted. This led you down a rabbit hole of looking up the varying diameters of 19th century US coins. This one is really good. I love it because even the query at the end is part of the poem. Two drovers meeting on their way, and thus they said it is true. If half your flock you give to me, I'll have just 82. Nay, friend, the other soon replied, add but a third to mine. Of your best sheep, then I shall have 129. His answer was exactly true. No scholar will impeach. Then by your knowledge show to me how many sheep had each. Apparently the answer is 21 and 122. See, I know, like, the calculations are there, and it's mostly just basic algebra, and to me, the value of this is in seeing how the problems were presented, because they're beautiful. Like, this is like a combination of math and language arts, which in my public education when I was younger, maths and language arts were very much separate. And we never would have encountered a poem as a word problem for a math class. So I really like it. Three men bought a grindstone, 50 inches in diameter. I demand how much of its diameter each must grind off to have equal shares. If one first grind his share, and then the next, until the stone is ground away, making no allowance for the eye. Okay, so we're talking a cylinder, a squat cylinder, ground through, the eye being the hole in the center of it. Poetry makes it feel like you're solving a Sphinx riddle instead of just doing math. I know, having them be poems makes it feel, I don't know, it's more fun. Ooh, I like this one. We have a long problem, then the answer, then the rule. We'll see how much I stumble over in reading this one. I knew I could do 2 hours of this. It's just too much fun. I was employed by a gentleman to take the dimensions of a certain cistern. When I commenced the job, it got... Wait. Yeah, I'm definitely stumbling over now. I was employed by a gentleman to take the dimensions of a certain cistern. When I commenced the job, it being in the afternoon, the time passed from noon was equal to 5/13 of the time to midnight. And when I had finished the job, the time passed from noon was equal to 7/11 of the time to midnight. I found the cistern to be in the following proportion. A diagonal line drawn from the bottom on one side to the top on the other bore such proportion in inches to the time I had been employed in minutes, as the staves bore to the top diameter. The top diameter was twice the length of the bottom, and the staves the length of both diameters. I demand the perpendicular height of the cistern, the time of day the job commenced, and how long I had been employed. That one is just complicated. I wonder how many of these I could repurpose as riddles for my D&D group before they notice I'm just making them do algebra homework. Let's see. Answer: 107.25 inches perpendicular height. 20 minutes past 3 p.m. The job commenced. The time employed 1 hour and 20 minutes. Okay. My first annoyance with this problem is the time passed from noon was equal to 1/13 of the time to midnight. We calculate time in base 12 and base 60. Not base 13. And then the amount of time he spent on it. He finished 7/11 of the time to midnight. Again, we don't use base 11. Time is base 12 and base 60. This would be one that would take me a while to work out if I was sitting down to do it, because my brain would get stuck on things, and I wouldn't, like, if I was taking a test or something, I wouldn't have the tools available to me to, like, really help me work through it, because I can't do it in my head. But all about that base, no variables. I love it. I love it, Siege. Rule: add together the numerator and denominator of the fraction, then as that sum is to 12 hours, so is the numerator of the fraction to the time when the job commenced. Proceed in the same manner to find when it ended. Subtract the less from the greater, and the remainder is the time employed. Then suppose a cistern of similar proportions, say 2 inches the diameter of the bottom, then will the diameter of the top be 4 and the length of the staves 6 inches. Then as 4 inches are to the time employed in minutes, so is 6 inches the length of the staves of the supposed cistern. To the length of the real diagonal line, find the square of the diagonal of the supposed cistern, and likewise the square of its perpendicular. Then, as the square of the diagonal of the supposed cistern is to the square of its perpendicular, so is the square of the real diagonal to the square of the perpendicular required, the square root of which will give the perpendicular. One of the things I don't like about the rules that he writes down in like explaining how to do the calculation, they almost always start with make up some numbers. Like, suppose you have a cistern of 2 inches diameter. Which, yes, that will work. I guess I struggle with it because I would have gotten in trouble for doing that. Because I wouldn't... when I was in school, I never would have just supposed 2 inches in diameter. It would have been X inches in diameter. Meaning that the top would be 2x and the length of the staves would be 3x. It is a very different approach. But it definitely works. It's just, instead of using a letter to represent the unknown quantity, they're just picking a number at random and doing the calculations with that, which I would definitely struggle with. Okay, let's see what this one. How far may a mountain be seen on land, ground, or at sea that is 2,000 feet high, supposing the eye of the observer to be elevated 5 feet above the surface? Answer is 57.6934 miles. Why are we going to 4 decimals? Rule. To the Earth's diameter in feet, because that's a constant everyone knows, add the elevation of the eye, multiply the sum by that height, and the square root of the product will be the distance where a level from the eye will strike the water. Proceed in the same manner with the mountain, and the sum of the 2 distances will be the answer, allowing the diameter of the Earth to be 7,970 miles. At least in his explanation, he includes the number he uses as the diameter of the Earth. Because it says, take the diameter of the Earth in feet. Wait, in feet? What? To the Earth's diameter in feet? So you first would have to convert miles to feet. Except his calculations, he starts with the number of inches in a mile. So why even bring feet into it? I feel like there were easier ways for him to answer these. Oh, we reached the bowl question. You're just like, I feel like I am not particularly great at math. I feel like there was an easier way to answer that question. Thank you for the self-care. All right, let's see how many more poem problems we can find. I love the ones that tell a story. I don't know that this one's a poem, but it seems to be telling a story. I went into a square field to mow, I cut around the field 15 times, cutting a swath 6 feet and cutting a swath 6 feet wide, and found I was half done. What was the size of the field? I mean, that's a pretty simple... That one's not as complicated as some of the poems. Mowing circular field in that one. Oh, this one looks interesting. Mostly just because the handwriting is really lovely on this one. If a solid globe of glass at the furnace whose diameter is 8 inches be blown into a hollow globe till the shell is but 1/5 of 1 inch in thickness, what will then be its diameter, and how much wine will it hold? The important question. How much wine will it hold? Okay, if a solid globe of glass at the furnace whose diameter is 8 inches be blown into a hollow globe till the shell is but 1/5 of 1 inch in thickness, what will then be its diameter, and how much wine will it hold? 20.655 inches in diameter. It holds 18.83 gallons of wine. Obi, it is the Marty McFly hat from, I think, Back to the Future 2. Might be Back to the Future. I don't remember. But yeah, I have a green screen behind me, so the hat is somewhat cloaked. Rule. Multiply the cube of the given diameter by 5236. Or, sorry, 0.5236. The product will... Okay, but... So this is the same... The last... when we had the other... It is 2015, yeah. Which is why the hat is appropriate. 0.5236. When we were doing the calculation at the very beginning of stream of the bowl and needed the circumference of the globe that the bowl would be half of, 0.5236 was also used there. It's not a number that I'm familiar with as to why, like, where that is coming from. Like, if it was like pi or something like that. Is it? But I don't know what 0.5236 is. That's no, it wouldn't be the square root of pi. I don't know what that is and how it relates to a circle. Clearly it does. I just don't know off the top of my head what it is because I am not a maths expert. Multiply the solidity by 5 because there would be 5 pieces each an inch square and 1/3 of an inch in thickness in 1 solid inch. How do you know that? But wait! I don't... How do you... So this is the rule used to do the calculation. Multiply the cube of the given diameter by 0.5236. The product will be the solidity in inches. Multiply the solidity by 5 because there would be 5 pieces each an inch square and 1/3 of an inch in thickness in 1 solid inch. How do you know that? And the product will be equal to the number of inches of the area of the surface of the hollow globe. Divide this by 3.1416 pi, and the square root of the quotient will be the diameter of the hollow globe, 20.655 inches. From this diameter, subtract twice the thickness of the shell, 0.4 of an inch, and the remainder will be the diameter of the inside of the hollow globe. multiply the cube of this diameter by 0.5236 and divide the product by 231, the number of solid inches in a gallon of wine. How do you know the number of solid inches in a gallon of wine? And the quotient will be the number of gallons it will hold, 18.83. It's about pi over 6. Okay. But, like, again, there are assumptions in here that I don't understand where they came from. How do you know that 231 is the number of solid inches in a gallon of wine? Water is about 5 pounds per gallon. Wine is close to that. It's all historical data. I mean, I understand that, but it's like, I have never heard this. So they just seem to come out of nowhere for me. Oh, here, this one. I'm mostly in this for the word problems that are written in unique ways. I agreed with a tinker whose name was Doolittle to make for my wife a flat-bottomed bottle. 12 inches exactly the depth of the same, and 25 gallons of beer to contain. The number of inches across on the top was twice on the bottom when new at the shop. How many inches across must the bottom then be? Likewise, on the top, pray show unto me. When you do brewing of beer and making wine, you have to know the specific gravity and density. I guess that makes sense. I know, we got another booze one. I like this one a lot. I agreed with a tinker whose name was Doolittle to make for my wife a flat-bottomed bottle. Or, it's not bottle, it's kettle. Which makes it rhyme better with Doolittle. I agreed with a tinker whose name was Doolittle to make for my wife a flat-bottomed kettle, 12 inches exactly the depth of the same, and 25 gallons of beer to contain. The number of inches across on the top was twice on the bottom when new at the shop. How many inches across must the bottom then be? Likewise on the top, pray show unto me. Slant rhyme at best. Yeah. And the answer is there, as well as like how to do the calculation and then the actual calculations. But I just love, like, if my word problems had been presented to me in poem, I think I would have liked them more. But I said earlier, Obi, when I was in school, math and language arts, never the twain shall meet. So poems as word problems, no, that never would have happened. I placed a bowl into the storm to catch the drops of rain. A half a globe was just its form, 2 feet across the same. The storm was o'er, the tempest past. I to the bowl repaired. 6 inches deep the water stood, I being measured fair. Suppose a cylinder whose base, 2 feet across within, had stood exactly in that place. What would the depth have been? Something something man to St. Ives many wives. This one is great, actually. I love this one. So, essentially, when you parse it out, when you see what's being asked, it's a bowl. So you have a half a sphere filled with liquid. And when it's half a sphere, the liquid is 6 inches deep. So if you then take that same amount of liquid and put it in a cylinder rather than a half a globe, how deep will it be? But being able to take the poem and turn it into the math problem, it's not that hard, and it's more fun to read the poem. Moving more in the direction of throwing random things at the students and getting them to discuss why they interpret things in each way, discussing whether each interpretation works, what complications arise, etc. Sunil Singh wrote a whole book about getting lost and doing math play called Chasing Rabbits. Some of these are improbable, like the nest that kept having X and a half eggs stolen from it. And I'm like, it seems problematic to steal half an egg out of a nest, because presumably eggs in nests are not hard-boiled, which makes taking half of an egg very difficult. So some of them are a little funny when you try to think of them in real-world terms, but they're still just really fun to read. Just rising from the sea, I've seen, when stationed in the shrouds, the lofty peak of Tenerife that penetrates the clouds. Just 50 leagues from it was I. My reckoning be true, and from the water to my eye the feet were 82. Suppose these observations just, to make the question brief, above the level of the sea, how high is Tenerife? Yes, Tenerife is a Canary Island. It's one of the Canary Islands. It is also the site of one of the worst airplane disasters in history. Which is why I know Tenerife, because I'm a disaster buff. So, you went last February? Yeah, it is supposed to be a pretty nice place. 14 teaching practices that move everything in this direction, building thinking classrooms. See, this to me is... I would have enjoyed it because of the poetry, which would have made me better at math. Because I would have been interested in it. The math for me is difficult because I can't do the calculations in my head. But when you present them in a way that is engaging to me, it makes me want to figure out how to frame the problem by parsing the poem, which then makes it more likely that I'm going to be able to do the calculations. Teaching to answer exams ruined a lot of education. I agree. Because, like, for me, the fun in this is parsing the question and taking it bit by bit, line by line. Here are the facts presented and what calculation is wanted, which is just writing the algebraic formula. And then the calculating of the formula, that's less fun for me, mostly because while I can do it, it takes me a lot longer than other people, and I used to get in trouble for how long it took me. Because I can't do it in my head. I need to have a paper to jot down notes on, or I need to count on my fingers because I can't. And I know now that the reason I can't do it in my head is that I can't picture things in my head. So I can't, like, hold the problem in my mind and manipulate it because I don't have pictures in my head. And so I needed something to be that sort of external memory, counting on fingers, or I used to put dots around the numbers as a means of calculating. Yeah, the teacher caught on to that and I got in trouble for it. So then I started putting the dots on the number because it was the act of making the dot that helped me to calculate. And as long as I was the only one that could see the dot, then that's all that mattered. Also great for getting you to split the problem into manageable sections by parsing the poem so your brain doesn't immediately go, ah, algebra. I actually enjoyed algebra. It was geometry that I hated, and mostly just because I didn't like proofs. Not because I didn't think proofs were important, but because nobody would explain to me why I needed to prove something that had already been proved. So I did not do well in geometry. If we were doing volume above 0.5236 was pi over 6, which is useful for the volume 4 over 3 times pi is the same as 8 times pi over 6. Proofs suck. I'm so bad at memorizing the axioms. Yeah. Yeah, no, I just didn't like proofs. My sister's years are just to mine, as 46 to 69. And if you multiply these over, the products in times, or the products 6 times 64. Show then our ages unto me, and I thy wedded wife will be. All other proffers are in vain, no other shall that favor gain. Yes, it is definitely not just a math problem. It is also a reading comprehension exercise, which is why which is why these would never have been presented in my high school as math, because they're reading comprehension. But if you were in a cohesive educational environment where you're learning reading comprehension and mathematics and like all of it as a whole, having poems as your math hits both at the same time. I love this. If you can do this calculation, I'll be your wife. I dropped a ball from Jackson's Bridge, its height above the stream to tell. A pendulum 2 feet in length made 5 vibrations while it fell. Can you in numbers fairly show how high this lofty bridge must be? Above the stream that glides below, the feet and inches show to me. We did actually attempt doing some calculations at the beginning of the stream. But rather than watch me struggle to do calculations while people are watching me, I moved on to just sort of reading the problems. And sometimes the explanation for how to calculate it. A rabbit to shun a greyhound swiftly ran, full 40 leaps before the dog began, and for her life so bravely she did strive. For every 4 leaps he gave, she gave 5. If 4 of hers were equal to his 3, to catch the hare, how many leaps gave he? You do have a channel, yes. That one's not a poem, it's just a word problem. Oh, wow, this one is very light. Thankfully, it's not a poem, so I don't feel like I need to read it. This would be the problem for me. The ones that aren't poems, I wouldn't want to do. We're not going to calculate compound interest. Thank you very much. It can be done, it's just annoying. And you have to set a cutoff point at some point. Otherwise, it just goes on forever. Aw. I reached the end of it. It is required to lay out 1 acre of land in a circle, on the circumference of which a horse may be fastened to a stake by a rope 20 yards long. How much of the acre will the horse be able to graze? You did this in calculus? The answer that they have here is 559.2617589 square yards. I'm really appreciative that not one poem is to calculate the size of an aspic mold. Yes. I don't know why there's a jump from where we were to some these problems here, but solution. There's a Quaker, we understand, who, for 3 sons, laid off his land, and made 3 circles meet, so as to bound an acre neat. Just in the center of that acre is found the dwelling of the Quaker. In centers of the circles round, a dwelling for each son is found. Now, can you tell by skill or art how many rods they live apart? And that's the diagram of it, which is nice, but honestly, I stumbled over rods being a unit of measurement, but who cares what word is used there? We can call it whatever we want. It doesn't even have to be a real unit of measurement. Although rods may have actually been a unit of measurement, I don't know. Anyway, this was a fun. Rods and chains are for measuring fields. Oh, okay. I did not know that. But yeah, this was a fun episode, surprisingly. I'm just going to read this one again. This is what we started with. This is the one that I attempted to calculate on my own. Oh, no, this isn't the one that it was the one below it that I attempted to calculate on my own. But this is what we started with. I wish a bowl to be made for me, just to hold 1 gallon of tea. How wide across must the mouth then be? A half a globe its form should be. And it was a very lovely calculation. See, with a calculator, you don't get the pretty. I actually would not be opposed to like just doing these calculations for fun. Just not on stream. Because you all don't need to see me struggle with math. This book, it's a gem. It's really, really fun to look at. It's just a math notebook from a guy that was a captain in the Confederate Army, an aide for Jefferson Davis during the Civil War, served in the Virginia House of Delegates, was a county surveyor for a Southwest Virginia county. He was also a teacher and a farmer. But the delight for me was the different way it presents math, so that it was more fun to actually read the problems. Because some of them had the meter of a limerick. A lot of them were about alcohol, and how to calculate how much alcohol was present in a volume, which I can see how students would be engaged with that content. Sadly, it would not fly in today's schools. But yes, this was fun. I'm glad I did this one. Thank you, of course, to my moderators. Hannah, thank you for being here. Key Squared, thank you for the resubscription. Shadows of Life, thank you for the bit. One was about tea. This is true. Of course, 16-bit Eric, thank you very much for the raid. The music has been Lo-Fi Girl. Next week, I do not have an episode. Next week, there will not be an Archival Adventures because I will be teaching a class. So, 2 weeks from now, we will be looking at Shortwave Experiment by Thomas Calvert McClary, the next in our sci-fi classics. And then the week after, the first Wednesday in October, we will be looking at the invention of the walkie-talkie. So, hopefully I will see you all for some future adventures in archival materials. Let me see where we are going to raid today. All right, we've got... We've done paleontologizing recently. You know, it's been a few weeks. And Steven was in chat earlier, so we're just gonna pop in on Stephen Joyce, a lovely streamer, ask about the tiny hats. And we'll just have a little fun with Steven as a little kitty in a big city. All right, we'll get that going. Thank you very much for joining me today. This has been a delight. I'm gonna look for more items like that. Not necessarily math, but it was just a lot of fun to read that notebook. But yeah, hopefully I will see all of you again in 2 weeks. Until I do, keep exploring history, everybody.